Greetings, everyone. Today we're going to go over graphing quadratics. Now, this is a tough lesson because there's a lot of information, but we also go over factoring and factoring to solve. So make sure that if you are absent, you take notes on this, pause the video when needed. We did have a handout for the first two examples, so that might be helpful with taking notes. Also, make sure you forward, rewind. After you listen to it once and take notes, maybe listen to it again and just watch without taking notes. Use this video to your advantage for the lesson, for reviewing, and before the test. Some prior knowledge needed as we continue through this process is to remember what standard form of a quadratic looks like. Your x squared value comes first, your bx term comes second, and your constant comes third. Remember, a is just the number, your leading coefficient, or the number in front of the x squared. Your b value is the number in front of your x, and the c is your constant. Let's go over a few terms before we work on our examples. The term parabola describes the graph of a quadratic function. Remember, quadratic means that the highest exponent is 2. That's one of our terms from the last unit. A parabola is also considered a U-shaped curve. So whether it's an upwards U or a downwards U, you're always going to have that U shape. Here's another new vocab word, concavity. Now, I remember this word based on the word that we recognize, cavity. If we think of a cavity in our tooth, it's a hole in our tooth. So we're looking at a hole right here that creates that curve. So the concavity is described by which way the parabola opens. It's either concave up, such as this blue parabola, or it's concave down, such as this purple parabola. Or Miss Marsh has a quick little way to remember. We can always say up like a cup and down like a frown. So that's a great way to remember. Remember, as we go through these terms, if I'm going too fast, pause the video so you can take the notes, or pause, write it down, then press play and just listen. The axis of symmetry. The axis of symmetry, you know the word symmetry from elementary school. Think of a flower. So in elementary school, we talk about how can I divide that flower into equal halves. So we're talking about the line that would divide the parabola into equal halves. So if I just look at the graph, that's pretty easy to find out. This particular axis of symmetry is x equals -2. Now, it's not always that easy. This formula right here is going to be your lifeline for everything we do in this section. We are going to base everything around this x value. So if you don't have the graph, but you have a function, you're going to plug in b for b, a for a, and you're going to solve -b over 2a. This value might be a positive number, a negative number, and it might even be a fraction, and that's okay. No matter what, it's going to be a vertical line of symmetry that we're going to represent with a dashed line on our graph. Now, this formula will make more sense when we apply it to a problem. Let's talk about the vertex of a quadratic. The vertex is the point of the parabola that crosses the axis of symmetry. So again, if I have my axis of symmetry here, this point is where my graph crosses it. You can also think of it as the top or the bottom of the parabola. This is the bottom or the lowest point. We represent it in point form. It's at -2, -3. That is my vertex. You can find the vertex by taking your axis of symmetry value and plugging it in for x to the function so you can find your y value. Your max or minimum. Your maximum is going to be the highest point on your graph. That would occur if you have a concave down parabola. This would be a maximum. If it's concave up, such as this one, this would be your minimum. So notice your maximum is also your vertex, and your minimum is also your vertex. You'll also notice the association. This is concave up, and this is concave down. Concave down always has a maximum. Concave up always has a minimum. All right, let's look at example 1. Again, my suggestion is possibly pause the video and write down the questions, and then resume the video to fill in. First, with every problem, you're going to have to write it in standard form. We've been stressing this with factoring. We're going to continue writing all of our functions in standard form. In this case, I am already in descending exponent order, and I'm missing my b term. So we want to think of it as 2x squared plus 0x plus 3, but we don't want to write that. Next, we're going to find that key value, that axis of symmetry. That axis of symmetry is solved by doing negative b over 2a. My b value is 0. So I'm going to plug in 0 for b. My a value is 2 because it's in front of my x squared. Remember standard form. So I'm going to put a 2. This would simplify down to 0 over 4. So that would give me a x value of 0. X equals 0 is my axis of symmetry. Now, that axis of symmetry is going to go into our table of values. The axis of symmetry is always going to go in the middle slot because everything is symmetrical around that value. So start with 0, then you want to pick values that are 1 greater or 1 less around that value. So if I go less first, I'm going to have a -1 and then a -2. Then if I go greater in the other direction, I'm going to have a 1 and a 2. Now, we want to do a little bit of work to find out what our y values are. So to start off, wherever there's an x, I'm going to put parentheses. I like to set all of them up at the same time. Yes, you can use your calculator for this portion. Sometimes I think mental math's a little bit easier, to be honest. And again, wherever there's an x, I'm going to put the x value that I'm trying to find. So I'm going to do a little bit of mental math. I'm going to start in the middle because 0 seems to be a little easier. 0 squared is 0. 0 times 2 is 0. 0 plus 3 is 3. I'm going to do the positives next. 1 squared, 1. 1 times 2, 2. 2 plus 3, 5. 2 squared, 4. 4 times 2, 8. 8 plus 3, 11. Let's go the other direction. -1 squared is still +1. +1 times 2 is 2. 2 plus 3 is 5. -2 squared is +4. +4 times 2 is 8. 8 plus 3, 11 again. So notice the symmetry. There's symmetry in the x's and there's symmetry in the y's. That needs to happen. If you don't see this nice symmetry and pattern, something's wrong. Now remember, your axis of symmetry is also where your vertex lies. So by creating this table, you also found your vertex point. So if I list my points, I have -2, 11. I have -1, 5. I have 0, 3. I have 1, 5. And I have 2, 11. We're going to take those points and we're going to plot them onto our graph. So as I plot these points, I'm going to start with my vertex. My vertex is at 0, 3. Then I'm going to plot -1, 5, and -2, 11 would be just off the graph. At 1, I'm at 5, and at +2, I'm at 11. Now make sure that this looks like a parabola. What I mean by that is it needs to have a curve. It needs to look like a U, not like a V, no straight lines. Sometimes it's easier to do the little curve first and then extend from there. Now, when I look at this graph, I can identify a few things. First of all, we can add our axis of symmetry, which is a dashed line through 0 on the x-axis. We can identify our vertex is right at this point. So if I'm asked to identify my vertex, I would say the point 0, 3. When I look at my U, it looked like this, which means I have a minimum at the vertex. Concavity, it's up like a cup, so concave up. All right, let's take a look at how we would try and factor and solve this. So this is from our previous unit. I'm going to think of this with standard form with a 0 in for the b value. It's equal to 0 because it says factor and solve. So to start off with my x, I would put a times c up top, that'd be 6, b on bottom, which would be 0. So I don't have any factors that would multiply to get 6, but add to get 0, because I only have 1 and 6 and 2 and 3. So that doesn't work. But if I look at the original equation, I could try to get x by itself, because there's only one x. If there's one x, try to just use your inverse operations, meaning subtract 3, divide by 2. Now the inverse operation of squaring is square rooting. When I square root a square, it goes away. What I do to one, I do to all. Now if you plug that in your calculator is going to spit out an error message. That's because you can't take the square root of a negative number. So that's actually no solution. There's no way I can solve this. There's no decimal values that'll work. So we're going to say no solution. Now when following math classes after this year, you'll get a little more in depth about what does that truly mean. It leads to imaginary numbers, but we're not going to get into that right now. So if you can isolate an x, try to do it. If it ends up with square rooting a negative, that's no solution. Let's take a look at another example. So first of all, I want to write this in standard form. Again, pause the video if you need to jot a few things down, then continue when you're ready. So I'm actually going to add 4 to the other side, which will give me an x squared, a -6x, and a +4. I can't actually add that 4 to a value because I have no like terms. So I'm going to put it on the end as its constant. Next, I want to find that axis of symmetry. -b, well, the negative's part of the equation, the formula. -6 is my b value, and 1 is my a value because there's a 1 right here. Now a double negative becomes a what? Positive, and 2 times 1 is 2, so this gives me a value of 3. So x equals 3 is my axis of symmetry. So remember that when we get to our graph. Next, I'm going to use that axis of symmetry as my middle value. So I need to go around 3 for my other values. So let's plug in a 2 and a 1, a 4 and a 5. So let's show a little bit of work here. Wherever there's an x, I'm going to put parentheses. So I'm actually going to do all the setup first. I find that a little bit easier. So maybe pause the video, fill in your work. I want to see something there. Be careful when using your calculator because your parentheses need to be exact. Your phone calculator isn't very helpful with these parentheses, so maybe download a calculator app or use a physical, scientific, or graphing calculator. Now I'm going to plug in my values. I'm going to plug in 1s for x's, 2s for x's, 3s for x's, 4s, because that's what my x value is, and 5s. Oops, that should be a 4 there. Now I'm going to do a little bit of mental work before I continue. 1 squared is 1. Negative 6 times 1 is negative 6. Positive 4. That's easier to type into your calculator to find the answer. I'm going to do all the work first. 2 squared, 4. 3 squared, 9. 4 squared, 16. 5 squared, 25. It's kind of easy when you do that pattern. Negative 6 times 2, 12. 6 times 3, 18. 6 times 4, 24. 6 times 5, 30. Plus 4, plus 4, plus 4, plus 4. So see, showing your work actually is easy when you follow the pattern. Now, you don't have to do it that way. However you calculate these, plug them straight into your calculator. If you can think of the mental math in your head, if you can think of it all without showing work and then jump to the y, do what you need to do to find out what your y value is. So now if I do the math, 1 minus 6, negative 5, negative 5 plus 4, negative 1. 4 minus 12, negative 8. Negative 8 plus 4, negative 4. 9 minus 18, negative 9. Negative 9 plus 4, negative 5. 16 minus 24, be careful with those larger numbers, negative 8. Negative 8 plus 4, negative 4. 25 minus 30, negative 5. Negative 5 plus 4, negative 1. Again, pause that video to do the calculations in your head so you can see where they really came from. Now notice the symmetry from the middle to the outside. That looks good. I see my consistent pattern in my x's. So now I should be ready to plot my points and see my graph. Now I'm going to plot my vertex first. My vertex is at 3, negative 5. Remember that that is also your axis of symmetry at x equals 3. So I'm going to draw a dashed line through x equals 3, my line of symmetry. My other points are at 2, negative 4, 1, negative 1, 4, negative 4, and 5, negative 1. I'm going to connect the smaller curve piece first, and then I'm going to extend through. Now don't extend too far because I don't know, oops, sorry, it's kind of bad drawing there. I don't know how far wide or skinny that's going to go. That's something we'll talk about later. So just go beyond the last point that you have found. So let's take a moment to identify our vertex. You found your vertex. It's always on your axis of symmetry, and it's always the middle value on your table. So we're at 3, negative 5. Our curve went up like a cup, so it's going up, concave up, and I have a minimum for my vertex because it's the bottom of the curve. Now let's talk about trying to factor this one. So to start off, it is set in standard form already. I will probably need it set equal to 0 because it says factor and solve. So that's like our previous assignment. So I'm going to start with my x because I've got a pretty traditional looking trinomial. 4 times 1 is 4, a times c, and my b value is negative 6. Well, my factors of 4 are 1 and 4 and 2 and 2. Are either of those going to get me to 6? In this case, no. So I don't have any factors that worked. So in this case, I'm going to say not factorable. Okay, so When you don't have factors that work, we're going to put not factorable for right now. Later in the unit, we're going to talk about what else could I do to find some values? Because it should work. I should get something, but it's probably decimals. So how can I find those decimal values? All right, thanks for pushing through. We got one more example. We've looked at one that was no solution. We looked at one that was not factorable. So let's see what other type of solutions we can end up with. Now, first of all, for this one, I want to write it in standard form first. Again, pause the video if needed. Now, first thing I notice is that I can move that 4 over, which would leave me with a negative x squared, a negative 1x, and a positive 6. Now, in class, I've mentioned a lot that we typically want to keep that x squared positive. So if you do that, I would also accept x squared positive 1x and a negative 6. So we're going to see how that plays out. How is that possible to have one with the signs that are opposite? Okay. Well, I'm going to stick to this negative leading coefficient first, and we're going to see how that relates to the graph. So next, I want to find my axis of symmetry. Negative b, well, my b value is negative 1. 2 times a, my a value is negative 1. So right here I can see how maybe those negatives are going to work themselves out. A double negative is positive. 2 times negative 1, negative 2. Therefore, my axis of symmetry will go through x equals negative half. That means that negative half is going to be my first x value. Now remember, you do not have to pick fractional values around that. Pick whole numbers that are around that negative half. Either look at your graph and determine what they are, or think of a number line. If I had this, a typical number line, negative half would be right here. So the numbers around that negative half are going to be negative 1, negative 2, 0, and 1. So now I want to show some work. Now, wherever there is an x, I'm going to put parentheses. Keep all of the signs that we have with our work. I like to be sort of systematic, so I'm going to write down my template or my function each time, and then I'm going to fill it in. All right, if I fill in those x values, I have a negative 2, negative 2, negative 1, negative 1, negative half, 0, 0, 1, 1. All right, as I do some work here, negative 2 squared is positive 4, but then I'm putting that negative on the outside with it. Negative 1 times negative 2 is positive 2, and then positive 6. If you want to use your calculator, please do so. And try this on your own. Pause the video and see if your values match up with mine. Negative 1 squared is 1. With the negative out front, it's negative 1. Negative 1 times negative 1, positive 1, plus 6. Here's where you definitely will need a calculator. I don't expect you to calculate these all with mental math. But we do have the rules of exponents that we've actually already learned. I can distribute that squared. So I'd end up with positive 1/4. So if you remember those rules of exponents, that'd be very helpful. A negative times a negative is a positive. 1 times a half is a half. Okay. We do know how to add fractions, but I'm okay if you choose to use your calculator. 0 squared is 0. 1 times 0, 0, plus 6. Doesn't even matter what the signs are here. Positives, negatives, doesn't matter. 1 squared is 1 with a negative out front. Negative 1 times 1, negative 1, and positive 6. All right, let's actually solve now. -4 plus 2, -2, -2 plus 6, 4. -1 plus 1, 0, 0 plus 6, 6. Here, I'm actually going to add the positives first. 6 plus a half is 6 1/2. 6 minus a quarter is 6 1/4, or you might put 6.25. 0, 0 doesn't matter, plus 6, 6. -1 minus 1 is -2. -2 plus 6, 4. All right, check that symmetry. I see the pattern from the middle moving outwards. So nice pattern. I just have a fraction I'm going to graph, and that's okay. So let's graph those points. All right, our axis of symmetry, I'm going to plot that first. That's at -1/2. So here's my axis of symmetry. Whoops, I'm a little bit crooked there. You will probably do a much better job than I am on this tablet. -1/2. My vertex is on there at -1/2, 6.25. So 1, 2, 3, 4, 5, 6, and a little bit. So it's going to be kind of right in the middle there. Of course, on your graph, it's going to look like it's filling up the box almost. My next value is at -1, 6. So right here, oops, I went down too far. And then I have a value. I'm going to kind of white that out there. And then my other value is at -2, 4. And then I've got 0, 6. And I have 1, 4. So I can see this curve. I'm going to connect those curved dots first and then connect the rest. Now I don't know how far out that would go, so I'm just going to extend it a little bit. So as I take a look here, it's going downwards, okay? Because it's going downwards, that explains this negative value out front. When you have a negative quadratic, a negative leading coefficient, your graph goes down. All right, let's answer some questions. Because my graph goes down, this is the first time we've had concave down. Because it's down, that also means that we have a maximum. So I'm going to have a maximum. And that maximum is going to occur at my vertex, which was at -1/2 and 6 1/4, or 6.25. If you do one value in a decimal, do them all in decimals, by the way. Alrighty, let's take a look at trying to factor and solve this example. So to start off, I'm going to take my standard form and set it equal to 0. As I prepare my x, a times c would be -6. My b value would be -1. I was jumping ahead there. I need factors of 6, which would be 1 and 6, 2 and 3, but that can get me to a 1. So that narrows it down to 2 and 3. And it's going to have to be a -3. So check your work here. 2 times -3 is -6. 2 plus -3 is -1. Now at this point, it depends what class you're in or what method you prefer. If you use grouping, I'm going to have you follow along on the purple. If you use the box, I'm going to have you follow along in the orange. So you might want to pause, fast forward, rewind the video for what works best for you. So those that did grouping, you'd write your first term, your new middle terms, and your last term. You're going to group. I can take out an x. I can take out a +3. I end up with the same thing twice, so that's good. I'm going to factor that common factor out, which leaves me with x plus 3. And remember, this is still all equal to 0. If you chose the box method, that would mean your first term goes in the first box, your last term in the last box. Your new middle terms get the middle boxes. This is the same amount of steps as grouping. I'm going to divide out a -x, a +2, an x, and a 3. So I arrive at -x plus 2 and x plus 3. Now we're factoring to solve. So we need to set each factor equal to 0. If I subtract 2 and then I'm going to divide by a negative. Here I'm going to subtract 3, and I end up at negative 3. So I have the values x equals negative 3 and x equals 2. So it factored nicely on this one. I have solutions. Now if you go back to your graph, plot those dots. Plot a dot at x equals 2 and a dot at x equals negative 3. You'll notice they are where your graph would extend to. They would be part of that same parabola. So if you have a solution, it should show up and make sense with your graph. So we're going to keep practicing these and working on these. Some will be not factorable, some will be a solution, and some will work out nice. And we'll start to explore, what does that really mean? What does that look like? So you should have an assignment or some work from Google Classroom. Let me know if you have any questions, concerns, ideas, and keep in touch.